Hello there, this is Glenn Barry from Dr. DMV LLC, and I'm back with another video. In this video, we're going to cover just one query, but it's a very useful one. This will be Query 32, Missing Indexes All Databases. This series of videos is going through the complete set of my SQL Server 2019 Diagnostic Information Queries. These queries are available for free at glensqlperformance.com/resources. Please keep in mind that I have other sets of SQL Server diagnostic queries for other versions of SQL Server, Azure SQL Database, and SQL Managed Instance. The queries you see demonstrated in this video are very similar or identical to the queries for older versions, and the same concepts apply. Let's take a look at the documentation for Query 32. This query reads from sysdmdb missing index groups DMV, which is documented here. It also reads from the sysdmdb missing index group stats queries DMV, the sysdmexec SQL text DMF, and finally the sysdmdb missing index details DMV. All of these are documented at these links. At a high level, this query simply tells you missing index information for every database on the current instance. It's ordered by index advantage, which is a calculated column that's a rough measure of how valuable a possible new index might be for your workload. Now let's go ahead and run this query and see what it returns in more detail. As you can see, the query returns 12 columns as I scroll back and forth. And don't worry, I'm going to go through each one of these one by one, but 12 columns of data come back. And we're going to take a look at each one now. So starting from the left is the index advantage column. And this column is a calculated column that's essentially a mixture of how often the query that's being called that generates this index request is happening and how expensive it is not to have the index. And whether or not 17,865 is significant or not depends on your workload, and also depends on how long SQL Server's been running. If you've only been running a short period of time and you have a relatively small number of users or a fairly small workload, that could be a very significant number. Whereas if you've been running for weeks or months and you have a very heavy workload, 17,000 is not going to be a very significant number. So that's going to be a judgment call based on your individual workload and how long you've been running. The next column over is the last user seek time. And that's really important because you want to look at that and think about how long has that been since that's been updated. So if you run this query and wait a couple minutes or even a few seconds and run it again, and that time updates, that tells you that whatever is triggering this index request is part of your regular workload, and it's going to be something you want to pay more attention to. The next column over is database schema table. And this just shows you which database and what schema in that database and what table in that database is where this missing index that SQL Server is asking for would go. Why we run this query now is it's showing us all the databases on the instance, and you can see all the index requests are for AdventureWorks LT 2008 R2 or for MSDB in the backup set table. And that's happening because of the Ola Hallengren backup queries, by the way. Moving on, the next column is missing indexes for table. And that just tells you the number of missing indexes that are showing up for that table total. And sometimes you're going to get many requested indexes on the same table, and you want to have some caution there because it's usually not a good idea to create, say, 5 or 10 new indexes on a table, especially if you're using this query to come up with those indexes, because quite often you're going to have a lot of very similar indexes that could be combined into one larger composite index that covered many of those same indexes. And it's better to have one wide index instead of multiple narrow indexes. And that ties into the next column, which is similar missing indexes for table. And in this case, it's just showing one on each one of these rows that are coming back. So that's going to be another clue that maybe you might have some indexes that can be combined if you decide to create any of those. So if we scroll over to the right and get to the equality columns, what that shows us is normally the equality columns are the columns that are in the where clause or in join clauses of queries that are triggering this request. And if it's just one column in that equality columns result set, that means that you can pretty much trust that. But if it's more than one column, like you see on this first row, for example, you need to be a little bit more careful. Usually I start off using that order in my index, but it might not be the correct order. And so you might want to do some more investigation to see which one of those two columns is more selective, for example, to make it better for the lead column in the index. And that goes the same way for the inequality columns. That's the next one in this result set. And again, if there's only one there, that's more significant than if there's two. You can trust it more than if there's two. But whatever's in the equality columns and the inequality columns coming back from this is what's going to be in the actual leaf level of your index if you decide to create it. And then the next column over is included columns. And the order of that doesn't matter at all. And you can expand this and see that there's even more columns that it's asking for here. And what this missing indexes DMV tries to do is it tries to create what are called covering indexes as much as possible. So usually these columns that show up here are in the select part of your query. And so just bear that in mind, and you can add more to that to try to create more of a covering index yourself if you combine several of these. So going further to the right, all the way over to the right, we have the user seeks column, and that's the number of times that SQL Server has asked for this index. It basically means how many times has whatever query or stored procedure that triggered this has been called since it's been keeping track here. And by the way, these numbers will get cleared out if there's any index changes on that table. So if you drop an index or add an index, or of course if you restart SQL Server, it's going to clear out these statistics. And so higher numbers are more significant here. And again, this helps you make a judgment call as to whether you want to create an index or not. The next one is average total user cost. And that's a calculation of how expensive it is not to have this index. So you can see 18.24 is quite a bit higher than 0.041, for example. And that just means you want to weigh that more heavily when you're deciding whether to create an index or not. The next column over is average user impact. And that's the percentage that the query optimizer claims that the cost of whatever query is triggering this would be reduced if it had this new index. So obviously closer to 100 is going to have more of an impact on the cost of that query, and you want to pay more attention to that. And then finally, the last column, which is only available in SQL Server 2019, shows you the first few characters of the query text. So in this case, it's a comment or the actual name of a stored procedure on most of these. And so that's really useful because now you know what stored procedure or what query is triggering this request. And that'll help you make a better decision on whether to create the index that it's asking for or not. And before I stop with all this, what I really want to go back to is don't go crazy with this query. A lot of novice DBAs and developers, they find out a bit about this query and they lose their minds. They run this query and it comes back with 100 rows or 200 rows, and they go out and create 200 new indexes. And that's usually a very bad thing to do. You're going to have an over-indexed database if you do that. And adding indexes to your databases has a cost. There's the cost of actually creating the index, and there's a space that it takes in the database when you create a new index. And also it hurts your insert, update, delete performance. So you don't want to go overboard creating new indexes. And you also want to look more deeply at a table that you're thinking about creating a new index and decide how volatile it is. If it has lots and lots of updates, inserts, and deletes, you want to be more cautious about creating new indexes. If you have more of an OLTP workload in general, you want to be more cautious. So again, this is a very useful diagnostic query, but make sure you don't abuse it. Use your judgment and look at all the parts of the picture before you decide to create lots and lots of new indexes at the same time. This is Glenn Berry, and I hope you enjoyed this video. Please don't forget to like, comment, and subscribe if you would like more content like this, because it really helps the channel out. Thanks for watching.